Hi everyone, welcome to Tech Agility Talk. I'm Monica Kikuru and my co-presenters are Purnima Rajendran and Michael Dennis. We all are software engineers at TD Ameritrade working on Advisor Client 1 application. Today we all are here to share our story of transformation journey. So before going to our transformation journey, I want to let everyone know that this is going to be a packed presentation, so please hold your questions at the end of the session. So let's go into our transformation journey. TD Ameritrade has been on modernization and transformation for the past 2 years to provide best-in-class client experience and to increase organizational focus, agility, and effectiveness. Our organizational vision is to transform software delivery process by leveraging XP practices and benefits of a cloud platform. Pivotal has been instrumental in guiding us towards the goal. Our technology leadership enabled a pilot project with Pivotal. And we were at a point where we started building out a brand new stack for Advisor Client 1. So this was how our team got on board with Pivotal engagement. This engagement kicked off 2 years ago and it lasted for 10 months. Now let's go into our areas of growth. Listed here are the areas of growth that were identified prior to 2 years. We'll deep dive into each of these and explain the challenges we faced and also the pitfalls and struggles that we came across because they are a huge part of learning and growth. Before deep diving into this, I want to talk a little bit about the Pivotal enablement and its impact in revolutionizing the software delivery process. Pivotal enablement made its impact on every level, starting from personal transformation as an individual and also meeting the high-level vision of organizational leadership. It introduced us to extreme programming principles like TDD, pair programming, CI/CD, collective code ownership, etc., which revolutionized the way we deliver software. We had lots of discussions about pros and cons of microservice architecture and when and how to break a monolith to a microservice application and how to implement 12-factor app. These all discussions helped us a lot when we started breaking our application into a microservice architecture. We learned different implementation strategies like reactive programming, domain-driven design, and such. We also learned to innovate whenever possible. Of course, we got into Pivotal platform, but more on it later. So now let's go into our areas of growth. More than anything, we were going through a huge mindset shift from project focus to product focus. So let us talk about this. When we kicked off engagement with Pivotal, team went through discovery and framing sessions with plenty of stakeholder meetings, exploration of different problems, brainstorming solutions, listing out goals, anti-goals, and tech stack decisions. At the end of synthesis, we came up with different personas to better understand our users and what they need. This led us to the mindset shift. Now let's talk about project mindset. What is project mindset? Project mindset focuses on the delivery. It can be some features or a software. Its main focus is on the output. A project mindset is a great approach to realize a set of activities over an agreed period of time to achieve a particular purpose. Problem here is it's often used incorrect. Smells that often occurs in project culture is assigning developers based on their availability in resource and planning tool, having big designs upfront, continuously changing team's composition, doing project management via Gantt charts, performing extensive reporting with lots of irrelevant information. A project that meets all deadlines, meaning within budget and original scope, may not result in the right product. There is more possibility for not learning anything during the project or not responding on the lessons learned. Of course, deadlines, scope, budget are important, but at the end, it's all about building the right product for the customer. It's all about continuously optimizing the delivered user value. Now let's talk about product mindset. What is product mindset and how it is different from project mindset? Product mindset mainly focuses on the outcome that teams delivers. It provides teams the freedom and responsibility to think of a strategy what they believe in will result in best product for clients. It facilitates teams in setting a process that supports them, also stimulating them to pull work instead of pushing it. This will result in a clear focus and offers an opportunity for sustainable pace of continuous delivery. Using such a product mindset means measuring success with business metrics like user adoption and retention, revenue, or cost generated per feature. We later witnessed for real how this focus shift led to less wastage, more releases, and more creativity. Now let's go into story writing. Good story writing stems from the need for building the right product. So let us dig a little deeper into this. Our challenges before pivotal engagement were, we had 20 plus point stories, and stories were written based on developers' availability and skills. That is horizontally sliced, meaning there was a clear distinction between the front-end and back-end developers. And there used to be separate stories for front-end and back-end. If a front-end or a back-end developer goes on a vacation, all their stories used to sit in backlog and wait for them. Or based on the priority, we used to pull developers from other teams. We have learned that writing stories and epics comprises the following principles: creating and representing product strategy and vision, focusing on achieving customer delight, continuously balancing priority, risk, value, learning opportunities, and dependencies with each other to determine next steps, and also creating roadmaps with frequent releases. One of the practices that we applied here is user-centered design. We adopted UCD based on user research. It involves paying attention to and understanding needs, wants, limitations of users, and analyzing and foreseeing how users are likely to use the product, and incorporating user insights to refine design. Let's talk about invest principle. Our product owners started writing stories with invest principle. Invest principle indicates independent, negotiable, valuable, estimable, small, and testable. Our stories became small, that is vertically sliced, meaning there are no separate stories for front end and back end, which enable full stack development and delivers measurable user value. It is important that your story should be as independent as possible in such a way that stories can be worked on in any order. It is important because it allows for true prioritization. Every story that you deliver should make your product more valuable. In terms of what to look out for story writing, if you want your team to be successful in this aspect, you have to watch out being able to perform user research and acquiring feedback on a regular cadence and finding appropriate staffing for the job. Also, for technically complex stories, developers may need to do spikes first and share their understandings, which will lead to better written stories. A better written story is an indicator for accurate pointing. Now let's go into sprint planning, which is one of the main XP practice. Before pivotal engagement, we followed Scrum, where we had to commit to a fixed number of points for every sprint. This limited opportunity for innovation and spiking out new technologies. Now we have rolling backlog and Kanban practice. We follow 1 week iterations. We have iterative planning meeting at the start of the week and retro at the end of the week. Now we have more room for innovation and trying out different things. We are not saying that Scrum is a bad thing. We are just saying that Kanban worked for us. Also, we have 2 different metrics to measure team's performance: velocity and volatility. Over a period of time, this have yielded more confidence to our product owner to predict a tentative timeline a feature will likely to take for implementation. Now Mike will talk about balanced team testing and code quality. Let me hand it over to him.
Thank you. So at this point, you might wonder how you could structure your team or best structure your team in order to support some of the goals that we've just discussed, and also some of the more technology-oriented areas that are to follow. So Monica's already mentioned some of the challenges that we faced in this area. Mix and match teams, teams aligned according to certain skill sets like server-side, UI development, that kind of thing. And also, especially in larger organizations, different areas of the business such as product, engineering, QA, design tend to be somewhat siloed. So we can enter the balanced team, which is a concept that was introduced to us during our pivotal engagement. It's a subtle yet powerful concept. In fact, we've heard about it so far at the conference a couple of times. There were some sessions earlier today on it. But if we look at the diagram, you can see the areas of the business represented. So in this case, we have product, engineering, design. You could include infrastructure, QA, whatever you want. But the key is the overlap in the center. So that represents all those areas or disciplines working together to build a successful product. So how do you know if your team is a balanced team? In our experience, your team should have some or most of these characteristics. Most importantly, it should be small, stable, and cohesive as opposed to mix and match. Everyone has to understand the problem space, what it is that we're trying to accomplish as a team. Members of the team obviously have their core competencies, but always with the whole team in mind. And the team should be cross-disciplinary with lots of collaboration. So the collaboration is really the key. So that's between product and engineering and design, and so on. And also decisions. Large decisions should be made as a team. And smaller decisions can be made as a group or at very least as a pair. The team should be self-sufficient, so it should be able to handle the work that is expected of it. But having said that, it is okay to reach outside the team at times for certain subject matter expertise. And I'd also like to mention the importance of regular retros. It's really been a benefit to our team having those whole team retros in a safe space where team members can discuss issues that might not come up in another setting, and also to learn from mistakes that we made, and also to celebrate the successes of the team. Right, so as I said, we're going to shift into sort of a more some more technology-oriented areas next. And the first one of those is everyone's favorite topic, which is testing. So some stuff about testing. It's not a goal in itself. It's more of a mitigation or a means to an end or a means to many ends. Like most traditional organizations, we had a heavy reliance on manual testing, which, as we all know, is slow and expensive and not always reliable. And it's also detached from development. And as a consequence, bugs or defects were often found weeks or maybe even months after the code was written, which makes them much more expensive to fix. And even worse than that is the developers tended to have a reluctance to touch working code. Anybody ever had that problem? If it's not broke, don't fix it. And that's a big problem, as we'll see. So at this point, I'm just going to say that automated testing is essential. It's really non-negotiable for modern applications that are being developed on a continuous integration, continuous delivery, or CI/CD model. So to achieve this, we followed two main strategies: test-driven development and shifting left. So I have a brief slide on anybody not know what TDD is? I'm sure you all do. I won't go into in detail, but I do want to say that it does actually mean that you have to write the test first. And that third step, which is refactoring, is actually very important as well. So it's not just writing the test that fails for the expected reason and making it pass, but it's also cleaning up afterwards. So what are the benefits? What are the benefits of test-driven development? There's a lot of them. I'm going to focus on a few that have been important to us. One is that it shortens that feedback loop from weeks to seconds, so that you know right away whether your code works as intended. That's really what shifting left is about. And it also creates what I like to call a testing harness that grows with your code base. And this facilitates the full automation of the CI/CD software delivery pipeline. And most importantly, it gives the engineers confidence to refactor their code. So let's talk about how to build your automated testing harness. One of the key goals is to maximize your test coverage so that you have as few gaps as possible. Where there's gaps, that's where bugs are going to creep in. As you know, a bug or defect, we like to say it's a test that hasn't been written yet. So if it does occur, then the most important thing is that you write that test that you didn't write initially. Make sure that it fails for the right reasons, and then you fix the code. So you might also ask yourself, well, why TDD? Why can't I just write my tests after the fact? And you could, but in our experience, we found that taking the test-driven development approach greatly reduces the gaps that you have in your test coverage. And to do that effectively, those small, clearly defined user stories that Monica mentioned are essential. As an engineer, you have to understand the acceptance criteria in great detail, but you also have to go beyond that and anticipate what could happen and carefully define your edge cases before you start coding. And you also have to decide how to test. There's a lot of different types of tests. Broadly speaking, we follow the testing pyramid. So for the most part, we rely on unit tests because they're closest to the code. They're less expensive to create and run. And then at the top, you have your end-to-end tests or browser automation tests, which are much more expensive and somewhat more brittle. So you want to have as few of those as possible, or no more than you need. UI testing, ours is a complex web application, so we have a complex user interface. It's also good practice to keep your business logic separated from your views as much as possible, and that will make your UI tests run a lot more efficiently. And finally, I'd like to say a word about contract testing. Like most modern applications, we started as a monolith. We evolved toward microservices, and in a microservices architecture, contract tests are absolutely essential. We decided to use Spring Cloud Contract, which has served our needs very well in terms of making sure that our services talk to each other properly and as designed, and we can test the producer and the consumer side from the same test. And one last thing, I would like to say that some amount of manual testing is okay and even desirable, especially if you have a complex web application, and we do some of that as well. The next topic is code quality, which is related to testing. Code quality for our team is really about managing tech debt. So tech debt is inevitable. It's going to grow or accumulate as your code base grows. It's like monetary debt. The longer you take to pay it, the more expensive it's going to be. So the question isn't how you avoid it, it's how you manage it. And if it's not managed properly, eventually it will slow down your ability to deliver software, deliver features. So like manual testing, we discovered that after the fact code reviews or peer reviews weren't compatible with the CI/CD approach, but constant refactoring is the key to paying down that tech debt, and you should expect to refactor as part of every story. And that's really the lesson here about having those automated tests, is to give you that confidence. And lastly, the concept is the concept of collective code ownership. We've got updates happening. Can't even see it on here. There we go. I can't get rid of that though. Oh.
Can you just move it to the edge of the screen?
Thank you, Purnima. There we go. Okay, all right. So pair programming is also a practice that we've adopted as a team, also called navigator driver. One of us will write the test and the other will make it pass. And there's many ways to do this. In our case, we rotate pairs every day. The idea is that we all work on different, well, we may not work on every story, but we work on every track of work, and we're constantly switching. So we work on the different features, but also across the stack. So that really helps support that collective code ownership. And next, Purnima will continue with deployments.
Thank you, Mike. So I'll talk about our transformation on deployments and sustainability. So when we say we're able to deliver more user value at a faster pace now, writing easily testable code that is efficient and effective is only a part of it. The other part of it is how fast we are able to deploy that code and take it up to production so that the users will be able to use those features and functionalities. A growing number of companies is shipping software in minutes. Most of us are aware of it. It's minutes and seconds now, not days, weeks, or months. So the buzz phrase that enables this is CI/CD, continuous integration, continuous delivery, and deployment. So as per CI practice, we integrate our code into a shared repository several times a day. We follow trunk development. We do use feature branches, but they are temporary. So whenever there is a broken build, no one in the team pushes code. Fixing it is the priority for the team. So every check-in is verified by an automated build and runs the test suite, enabling us to detect errors more quickly. So XP practices are all about feedback loops. More specifically, CI's purpose is to provide feedback as soon as possible. And we try and keep the feedback CI loop as short as possible. So for instance, at one point, we parallelized our UI tests and reduced the runtime of tests by 2/3. And at another time, we pulled out the integration tests out of our main build pipeline so that the flaky downstream services do not impact our ability to push code. Moving on to continuous delivery, the main principle here is frequent small deployments. So we have a 2-week release cadence, not exactly CD, but we're getting there. So since our deployments are more often and work in small batches, the risk of doing deployments is lower. So for bigger epics and functionalities, we leverage feature flags, which we turn on in lower environments so that the code is continuously integrated and tested, and turn it off on production so that the incomplete functionality is not accessible by the user. So continuous deployment requires that the same artifact be deployed in all environments, which means for the deployments to be smoother, each environment must be similar. Development and testing, staging should be production-like. Production is not something special, but it's just another stage in the pipeline. So homogeneous environments are hard to achieve, but the idea here is to use the same tooling, process, and configuration for all environments. So we have a homegrown in-house deployment tool, Release and Deploy tool, which aids us greatly. So it produces a immutable release unit with the service binaries and configs that can be promoted to any higher environment with a single command. So this tool also provides us different deployment options to us, like the blue-green. So we could choose to deploy the whole stack with the green URL, and after successful validation, the green URL could be flipped to the blue route. So how does a Pivotal platform, a platform as a service, fits into all of this? Well, Pivotal platform made most of this possible and very convenient. So this is what we were doing before. So whenever there was a new service, we used to raise requests for servers or VMs. So the provisioning of physical servers could take weeks, and VMs took lesser time. So after the provisioning, we used to set up the environment and config for the servers. Then we would create Jenkins jobs manually and plug in shell scripts into these jobs that would deploy the var or jar into the VM. We had a 6 to 8 weeks release cycle involving enterprise QA, regression, and release management. We sometimes even pulled all-nighters during releases. So after transitioning to Pivotal platform, all we do now is write and commit code. So Jenkins file and CF push takes care of the rest for us. So for higher environments, we still do raise requests to create spaces for new services and some whitelisting permissions, but that's about it. Our releases are so fast now, and we deploy right after market hours. It's no more release all-nighters. There are so many advantages using PaaS. So the most impactful to us were some are listed here. So faster time to market. So this is a no-brainer. So automating previous manual steps reduce time to market dramatically, weeks to days in our case. So more responsive means automated deployments means being able to deploy changes faster. Automated scaling means being able to respond to demand faster. So the sizing decisions can be made right up to the deployment time. So no need to like arrange for capacity weeks in advance. So we have experienced greater efficiency firsthand in terms of increased productivity, resource utilization, self-service, and automation. So with Pivotal Platform, the deploy target is always clean. So that is, the future deployments are not affected by the debris of past deployments. And it's easier and more effective to keep multiple environments in sync. So I'll give a quick example of automation. So a couple of weeks ago, we had a host failure in production, and Pivotal Platform rescheduled all the apps that were affected and rebuilt the platform VMs to restore full capacity. No one had to intervene to make any of that happen. So that is the power of automation. So a question for you. As developers or at an enterprise level, if you're contemplating using PaaS for your organization, what is the relationship you would like to have with your PaaS? So as developers, we want to be spending time creating and pushing features into the hands of users instead of having to worry about infrastructure, operation, platform, and talking to operations. So using this metaphor of pizza as a service, we are only supposed to concentrate on what we want to accomplish. So only care about your pizza. Everything else is someone else's concern. So at an enterprise level, the main advantage is that they gain environments without having to build or maintain infrastructure. But what happened at TD Ameritrade was that Pivotal Platform had to be laid out over TDA Cloud. So we needed expertise to architect, set up, and run the platform. So we are a dev team, not a DevOps team. So we did not have to configure Pivotal environment spaces or environments. Our ops team takes care of it for us. So this is something you want to be mindful as to who will be responsible for what. Finally, a bigger question. How do you sustain such successful practices in a large organization? So when our engagement was still on with Pivotal, we used to have several knowledge sharing sessions with the teams back home. So they had already started testing the waters with TDD, story writing, and other practices. So when our engagement was done and when we were back, we did not give up what we learned. We were and are still holding it all together because we have seen the results and realized how valuable the practices really are. So then we helped enablement with other teams. So we have had book clubs and discussion forums for fostering innovation, bouncing of ideas, providing and acquiring feedback. So another idea was to employ crossover pairing between the teams for effective exchange of knowledge and practices. So all of this led to something called cooperation. So the first time I heard this word, I wasn't even sure if it was a real word. My 10-year-old had to clarify it for me. She was like, "Mommy, it is cooperation and competition combined together." So it's one of the core values in the first Lego League robotics competition. That's how she learned it. So when I witnessed what was happening among our own agile teams, I thought that was the appropriate term for it. Cooperation in a progressive and good way. So which means the engineers are empowering each other, benefiting themselves, their teams, and the organization itself eventually. So what works better for an organization more than empowered employees? So following all these practices helped us achieve many things. So I will talk about a few. So we were able to successfully transition our application into a RESTful microservices architecture. We have implemented Spring Cloud Gateway as a routing app for our backend for frontends. So we religiously followed domain-driven design for all our microservices, along with consumer-driven contracts and other testing patterns. So we were able to spin up a demo site, where the whole application comes up with stub data through and through, leveraging domain-driven design. So this site provides incredible value to our sales and marketing folks to promote the site. So this is what lays ahead of us. So we are piloting implementation of service discovery and registry for the microservices architecture. We are also looking to incorporate client-side load balancing and circuit breaker patterns. So there are ongoing efforts towards deploying each microservice independently. We're also looking to introduce a suite of acceptance tests, which would eventually replace enterprise QA cycle. So that's all we got. We hope that we were able to share some important nuggets from our tech agility transformation experience with you all within the time limit. And more importantly, hope this information is of good use to you in your own transformation journey. So thank you all for taking your time to attend this talk. So please reach out if you have any questions.